Ever wondered what makes our planet so special? Welcome to Class Bites! Today, we're diving into the incredible layers of Earth's atmosphere. Imagine the Earth wrapped in a vast, invisible ocean of air, a protective blanket that makes life possible. This is our atmosphere, a surprisingly thin layer of gases held close by gravity, yet deep and complex enough to create the rich tapestry of weather and climate that defines our world. It is not a single uniform entity, but is structured in distinct layers, much like a multi-layered cake, each with its own unique character and role in the planet's grand design. Closest to the ground is the troposphere, the stage upon which the drama of our daily weather unfolds. Extending several miles up from the surface, this layer is the densest, containing most of the atmosphere's mass, including nearly all of its water vapor. Here, the air is in constant motion, stirred by the sun's energy warming the land and sea below. As you ascend through the troposphere, the temperature drops steadily, a familiar reality to any mountain climber. This is the realm of clouds, rain, wind, and storms, a turbulent and vital zone where the fundamental processes of our climate system begin. Above this familiar world of weather lies the stratosphere. Here, a curious reversal occurs. The temperature begins to rise with altitude. This warmth is generated by the ozone layer, a crucial shield within the stratosphere that absorbs the majority of the sun's harmful ultraviolet radiation. The air in the stratosphere is much thinner and drier than below, creating a stable environment largely free of the turbulence that characterizes the troposphere. This calmness makes it an ideal cruising altitude for jet airliners, offering a smoother ride far above the stormy weather. Venturing higher still, we pass through the mesosphere, a region where temperatures once again plummet, reaching the coldest points in the entire atmosphere. This is the layer where most meteors, drawn by Earth's gravity, burn up upon entry, creating the fleeting, fiery streaks we call shooting stars. Beyond the mesosphere lies the thermosphere, a vast layer where the air is incredibly thin. Despite the scarcity of molecules, the energy they absorb from the sun is so great that temperatures can soar to extreme highs. It is in this ethereal realm that the beautiful auroras dance, and where the International Space Station orbits our planet. Finally, the exosphere is the atmosphere's outermost fringe, where the air gradually thins and merges into the vacuum of space. This layered structure is the setting for a magnificent planet-spanning engine of circulation, driven by the simple fact that the Earth is heated unevenly. The sun's rays strike the equator most directly, delivering intense energy that warms the air, causing it to rise and creating a belt of low pressure. This rising warm air doesn't travel in a straight line to the poles. Instead, the planet's rotation deflects its path. This interplay of heat and rotation organizes the atmosphere into three giant circulating cells in each hemisphere: the Hadley, Ferrel, and polar cells. The Hadley cells are the great engines of the tropics. Warm, moist air rises at the equator, cools, and releases its moisture as heavy rainfall, which is why lush rainforests are found in this region. This now dry air travels poleward high in the atmosphere, eventually sinking around 30 degrees latitude. The sinking air creates high pressure zones, leading to clear skies and arid conditions, which explains the location of many of the world's great deserts. At the other extreme, the polar cells involve cold, dense air sinking over the poles, creating high pressure and then flowing toward the equator at the surface. Sandwiched between these two are the Ferrel cells of the mid-latitudes. They are driven not directly by temperature like the others, but by the motion of the neighboring Hadley and polar cells, acting like a gear in the larger atmospheric machine. This complex interaction of rising and sinking air across the globe is the foundation of our planet's climate zones, a system that constantly redistributes heat from the sweltering equator to the frigid poles, preventing either extreme from becoming more so. Flowing within this grand circulation, primarily at the boundary between the troposphere and stratosphere, are powerful, high-altitude rivers of air known as the jet streams. These narrow bands of extremely strong wind, typically blowing from west to east, are born from the sharp temperature differences between the giant air masses of the circulation cells. The greater the temperature contrast, the faster the jet stream flows. There are 4 main jet streams, 2 polar jets and 2 weaker subtropical jets. These jet streams do not follow a straight path. They meander in great looping waves across the globe. Their position and strength shift with the seasons, moving toward the poles in the summer and toward the equator in the winter. The location of the jet stream has a profound influence on our weather. It acts as a steering current for storms and a boundary between cold polar air and warm tropical air. If the jet stream dips south, it can bring a blast of cold air with it. If it shifts north, it allows warmer conditions to prevail. The path of these atmospheric rivers is what makes weather in the mid-latitudes so variable, determining whether a region experiences a prolonged drought, a series of storms, or a persistent heat wave. Together, these elements, the layered structure of the atmosphere, the global circulation cells, and the meandering jet streams, form an intricate and interconnected system. The sun provides the raw energy, the Earth's rotation provides the spin, and the laws of physics orchestrate the dance. This constant large-scale movement of air is what creates climate. It is the system that carries moisture from the oceans to the continents, shapes our prevailing winds, and dictates the fundamental patterns of temperature and precipitation that define the character of every region on Earth. It is a dynamic and ever-shifting balance, a global climate engine that works ceaselessly to moderate our planet's temperatures and create the world we know. Thanks for watching. Please like, subscribe, and comment below with your thoughts or what you'd like to see next.